The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
So for number 6, the last problem here, we need to show and state which theorem we're using to deduce the sequence defined by the following here. A sub 1 equals 1, and every subsequent a sub n plus 1 is 3 minus 1 over that a sub n. We want to show that this is increasing and that a sub n is less than 3 for all n. So the way we're going to do both of these actually is by using mathematical induction. So for part A, we need to show that it's increasing. So we need to show that for every a sub n plus 1 is larger than it. So to do this by mathematical induction, we need to show that it's true for the base case. So we're given that a1 equals 1, so we need to show that a2 is bigger than that. So a2, using this formula, is 3 minus 1 over a1, and a1 is 1, so this is 3 minus 1, a2 is 2. Okay, so a2 is clearly bigger than a1. So for mathematical induction, then you need to assume that for some random number k plus 1 is for sure bigger. Then go to the next step. So this is base case here. So now assume, so we're going to assume that a sub k plus 1 is greater than a sub k. So if we are assuming this and we can show that this means a sub k plus 2 is bigger than a sub k plus 1, in other words, the next step past these two, we're showing that if any step is true, the next step is true. And since we started with the base case being true, that means the next step after the base case is true. And then if that is true, the next one is true, and on and on and on and so forth. So we just need to show that this translates into the next way. Well, let's try. So your strategy for this is try to transform this inequality to look like this equation. So what we're going to do is first reciprocate both sides. So if a sub k plus 1 is greater than a sub k, that should tell you that the reciprocal is less than a sub k. Sorry, less than 1 over a sub k. Okay, so if this is a larger number, 1 over it is definitely going to be smaller than 1 over a sub k. And for the sake of this problem, we can assume that these a sub k plus 1, etc. are all going to be positive numbers. We don't need to worry about messing with the inequality there. So that part is starting to look like this part of the formula. What needs to happen next is these need to be negative, and then we need to do 3 minus those. So if we want to put a negative sign in front of both of these, in other words, multiply by a negative, we have to change the inequality back to facing to the left. Okay. So all this started with here, and we're just doing basic arithmetic now to this. And finally, we are going to add 3 to both sides. So adding 3 to both sides, of course, does not change anything about the inequality. So now we got two things that are exactly in the form of our recursive definition. 3 minus 1 over a sub k plus 1 would be a sub k plus 2. And 3 minus 1 over a sub k would be a sub k plus 1. So we can see here that assuming this, we get that this is true. So this means for any two numbers back to back, the next two numbers also follow that. Or sorry, just the next one compared to the top, to the bigger one here. Also that inequality holds. Therefore, by mathematical induction, this is true for every step, which tells you that this sequence is always increasing. Every subsequent number is going to be bigger than the one before. So that's the proof that it's increasing. To show that it's less than 3 for all n, we're going to do something very similar, and that's going to be in our next video.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.